am now going to show you how to create a MinIO tenant using a MinIO operator. This is our Kubernetes cluster. As we can see, there is one master node and 4 worker nodes. To start with, on the worker nodes, we connect and discover the NVMe volumes from the Poseidon target. The drives NVMe1 and 1 to NVMe1 and 8 are coming from Poseidon target. Now on the master node, the direct PV CSI driver will discover these Poseidon drives and mark them available. We can see the drives have been marked as available. We will now format this pool of drives using the direct PV CSI driver and move them to ready state to be consumed by Kubernetes cluster. We can see the drives have been moved to ready state. Once the drives are in ready state, now we will initialize the MinIO operator. We can see the MinIO operator pods are up and running in the Kubernetes cluster. On another master node terminal, we create a local proxy to the MinIO console to access the MinIO operator UI. Let us enter the copied token. To create a tenant, we hit on a create a tenant button. This will land us to a page where we need to enter the setup details of the tenant we want to create. We have updated these details. We have updated the name of the tenant, the Kubernetes namespace in which our tenant will reside. Please note that only one MinIO tenant per Kubernetes namespace is supported. We updated the storage class to direct PV MinIO. This storage class is associated with the direct PV CSI driver. The MinIO operator will generate the persistent volume claims or PVC against this storage class and therefore consuming the Poseidon storage. We have updated the number of servers to 4. So there will be 4 MinIO servers created in this tenant. Drives per server to 4. So the total drives in this tenant will be 16. Considering each drive to be of 2 TB capacity, the total size of the tenant will be 32 TB. We have updated the eraser code parity to EC4. Then we updated the resources like CPU request and the memory request for the MinIO server pods which has to be created. We can see the values on the right pan has been updated as per the values entered in these fields. Then we update the other sections like images, pod placement, identity provider, security, encryption, audit log, and monitoring. Please note that for audit log and monitoring, we have to update the storage class to direct PV MinIO so that they are able to get the volumes from the Poseidon storage. Now we hit on the create button and wait for some time so that the required pods are created. This will generate the credentials which has to be saved for later use. Now we can see the MinIO tenant is up and running and the state has been set to initialized. Also the health is green. Let us go to the monitoring dashboard. We can see different metrics in this dashboard like users, traffic, resources. This gives us interesting insights into the created tenant. Now on the master node terminal, we will see the pods corresponding to these tenants. We can see these pods have been created corresponding to our MinIO tenant. These are the MinIO server node pod which have been created, and this is the Prometheus pod for monitoring dashboard. Let us also check the service created for our MinIO tenant. So these are the NVMe-oF services created, which we will use to access the NVMe-oF. In a similar way, we can create another tenant with altogether different sets of parameters using this create tenant button. The two or more created tenant will be truly independent of each other, and the beauty of it is we are able to achieve this using the same physical resources. With this, we have just completed the successful deployment of the STaaS with Poseidon Storage on Kubernetes.